One. Let's solve for the sketch the graph of each of the following. This is 14I question 2d. All right, 2d. You want to sketch the graph. So, a couple of things. Let's work out period. Amplitude. What's the amplitude in this case? 2. Very good. Amplitude is 2. Written by there. What is the period, Lockie? Remember, the formula is 2 pi on n for sine and cosine. So 2 pi on 2, which gives you? Pi. Very good. So this is my n value, and that's my a for the amplitude. Very good. So you got your period, you've got your amplitude. One of the first things you need is y-intercept, and then later on x-intercept. Y-intercept occurs when x equals 0. So here we go. Y is equal to 2 times cos of 2 times 0 plus 1. What's cos of 0? Which one is it? Think about the unit circle. What does cos represent again? X or y? X. Now look at the unit circle. 0 starts at this point. It's 1, see? All right, good. Picture the unit circle. So it's 1. 2 times 1 plus 1, that gives you now 2 plus 1. So I now know the y-intercept is at 3. Okay? The only part we don't know yet, x-intercepts. Here we go. X-intercept is when you let y equal to 0. And here we go. 0 is equal to 2 times cos of 2x plus 1. Minus 1 on both sides. Divide both sides by 2. Cos inverse both sides. So therefore you're left with 2x is equal to the cos inverse negative half. This is where you pause and then you think about your unit circle. Here's my unit circle. Cos represents x values, and I'm asking when is cos, the x values, negative? Yes, or not negative pi on 3, but just pi on 3. And which quadrants?
Quadrants 2 and 3.
Good. This is when x coordinates are negative. So we know this is when we want negative half here. And yes, there's these 2 points. And you just told me the reference angle is pi on 3. All right. So assuming we just work from 0 to 2 pi, that means this is pi here. Yeah, we do. Forget about it. Because remember, once you find the first 2, you just add and subtract the period. So just get the first 2 regardless. I always just find 2, and then I just add, subtract, and the ones that don't fit in the domain, I cross off, and then I just keep the ones that do. Yeah. You can. That is the proper way to do it. I just can't be bothered. I just get any 2. So any 2, since this is pi here, then I can go add by pi and 3 and subtract by pi and 3. Yeah, so pi, minus pi and 3, pi plus pi and 3. And remember, this is still 2x, and that's 2x there. Pi minus pi and 3 is 2 pi and 3. 3 plus pi and 3, pi plus pi and 3 is now 4 pi and 3. Divide both sides by 2, so x, my 2 possible x-intercepts are divide, and this is 2 pi and 3. If I've done it too quick, what I did was I just said divide this. When you divide by 2, your times in the bottom by 2, and then I can see the 2's cancel out. 4 divided by 2. That's all I did. So pi on 3, and this was 2 pi on 3. Okay, now you got your first 2, and the domain you said was from negative pi to 2 pi, right? So I need to work negative pi to 2 pi. That's where I got to work. The period, which Lockie told us was pi. And so in that case, since it's out of 3's, you just got to add, subtract, right? So I just got to change it to out of 3. So 3 pi out of 3. Now let's add and subtract them. So you're adding 3 and subtracting 3. So if you follow that, let's add 3 to both of them. You could get 4 pi on 3, or you can get 5 pi on 3. Still within the domain. Sounds pretty good. And then add another 3, so that gives me now 7 pi on 3 and 8 pi on 3. Too far now. Now I go backwards. Take away by 3. So 1 take away 3 is negative 2 pi on 3. And 2 take away 3 is negative pi on 3. Still within the domain, because we said negative pi to 2 pi. And so that means I do another subtraction of 3. So if I take another 3, that gives you what? Negative 2 take away 3 is negative 5 pi on 3, too far. And negative 1 take away 3 is negative 4 pi on 3, and again, too far. So what are my acceptable x-intercepts? We have negative 2 pi on 3. We have pi on 3. We have 2 pi on 3, which is the first two that we got. And then the other ones that were acceptable is 4 pi on 3, 5 pi on 3. And we crossed off the other side. I have 1, 2, 3, 4, 5 possible x solutions.
Could you do the same thing if instead of using 2 pi on 3 would be 4 pi on 3, use pi on 3 and 5 pi on 3?
Let's say that again.
Like, do you know we started at 0? If we started at negative pi and 2, like, things were pi on 3 and then 5 pi on 3, like the 2 to the next thing.
So you got these two.
No, when I first started off, I got pi on 3 and 5 pi on 3. It got lost. Instead of a 2 pi on 3 and 4.
Oh, this one.
That did not. The very good
First two bits. You ended up with pi on 3 and 5 pi on 3.
Yep.
No, that's wrong. It's something... I mean, you can. You can, yeah, because I said as because there are two positions there. One's in quadrant 2 and one's in quadrant 3. So your quadrant 2 version was pi on 3. So you had a pi on 3 for this one. And then your quadrant 3, you had this one. Yeah, because each one is a pair. So this is quadrant 2, quadrant 3, quadrant 2, quadrant 3, quadrant 2, quadrant 3, quadrant 2, quadrant 3. So as long as you've got one of either quadrants. So actually, no, you can. You can have those two. And yeah, yeah. So let's say you had pi on 3 and you got 5 pi on 3, yeah? So this represents the quadrant 2 possible solutions, and this represents the quadrant 3 possible solutions. So all I'm doing, when I add pi on 3, is I'm seeing how many times does it come back to quadrant 2 that still fits in the domain. So all I would have to do is just add on the period. And the period was pi, but pi is the same thing as 3 pi on 3. So I just add on 3. So for quadrant 2s, all my possible solutions are 4 pi on 3, add another 3 is 7 pi on 3, and now I've gone too far. So then I subtract. So I go backwards. I say subtract by pi on 3. I will subtract by 3. So that gives you negative 2 pi on 3, and then negative 5 pi on 3. So which ones are acceptable? Negative 2 pi on 3, pi on 3, 4 pi on 3 are for the quadrant 2 solutions. Then quadrant 3, since you got this one, then you do the same. Let's add and add until you're out of the domain. So adding on 3 pi on 3, so that gives you now 8 pi on 3 out of the domain. So you go backwards. You go, all right, let's subtract. So subtract 3 pi on 3. So subtract 3, that gives you 2 pi on 3. And then take away 3 again is negative pi on 3, still within it. Take away another 3, it's negative 4 pi on 3, and now we're too far. So which ones am I acceptable? Negative pi on 3, 2 pi on 3, 5 pi on 3, and that gives me a total of 6 there. Yeah.
I think I messed up with the 2x. I had them all at 6.
You had them all at a 6.
It makes sense.
Yeah, because all it is we just simply get one solution from either. And this is why I was saying tan is easier, because you don't have two quadrants you have to worry about. You only need one. And you just keep adding the period, and you keep getting them all. Sine and cosine is different because you need one of each quadrant. So you need one for quadrant 2, you need one for quadrant 3, and then you add the period every time just to get back to the spot. And this one you add the period until you get back to the same spot. That's why it's a bit trickier for students to understand that you can have two possible answers. Or sine or cosine. Does it make a bit more sense there? And then the sketching bit, pretty straightforward. Put it all together. Cos of 2x. Cos we know usually looks like this. It's going from negative pi to 2 pi, but since it's gone up by +1, so your amplitude normally is from -2 to 2. It's now gone up by 1, so it's now -1 to 3. So it looks something like that. Usually your cos graph goes like this. Okay. Is it a negative graph or a positive graph? Positive. So it's gone up, comes down, comes back up in a period of pi. So that means I can do another one and finish at 2 pi. Means I can do another one and finish at negative pi. Y-intercept was that 3, wasn't it? Should be 3. Yeah, I didn't even have to actually sub it in, but y-intercept is clearly 0, 3. X-intercepts, you should have 1, 2, 3, 4, 5, 6, which we had was negative, what was it again? Colored it. -2 pi and 3 and negative pi and 3. Yeah, so this is -2 pi and 3. This is negative pi and 3. This was our original. 2 pi and 3. And then you had 4 and 5. I think, yeah. We haven't done the endpoints, but pretty much based on the graph, we can tell this should be negative pi 3, and this should be 2 pi 3. Because when I was doing any horizontal translation, it was just a shift. So it used to be here at 2, negative 2, it just shifted up to negative 1 to 3, just like that. That's why vertical translations are easier. Because as long as you know the first shape, and the rest is all symmetrical. Good? All right. Stop the video there.